And so we're ready to finish up the review part of our notes. Just as a quick reminder, we've covered things you may encounter when you work with fractions, as far as how to reduce fractions, how to add, subtract, multiply, divide fractions. We have worked with combining like terms, using the distributive property. We worked with rules when working with signed numbers. Let's see if you can just tell me those rules real quickly. So if I wanted to add two negative numbers, and in fact, let's do this real fast so we can kind of review this as well, because I didn't have this in our quiz we just did. If we were going to add a -3 plus a -7, what would that equal? Okay, I hear one vote for a -10. Does anybody else agree with that? I've got some people who are still thinking. So let's see if we remember the rule. Remember, we look at whether we've got same sign or different sign. So when we're adding and the sign is the same, what's the rule?
Flip the signs.
You're going to keep the same sign and do what with the absolute values of numbers? Add. So because it's -3 plus -7, they're both negative numbers, add 3 plus 7 and you get 10, and then the answer is going to have the same sign, -10. Now, what if this had been a +4 plus a -9? What would that be?
-5.
Okay, I'm hearing several of you say -5 now. That's right, because if I'm adding and the signs are different, what do I actually do with the numbers? Subtract. And so 9 minus 4 gives me 5, but my answer takes which sign?
The sign of the greater number.
The sign that has the larger absolute value. 9 is a bigger number than 4, and 9 is negative, so the answer is negative. Okay, does that kind of ring a bell? What about if I were subtracting, and if I had a -3 minus a -6, what would that be? What's the rule tell me to do when it's subtraction? Change it to adding the opposite, which means I've got to make how many marks? 2 marks. So I never do anything to the first number. You leave it alone, but you change to adding the opposite. So my minus sign becomes plus, but this negative sign becomes positive. And now I'm adding a -3 plus a +6, which is how much? A -3 plus a +6 is a +3, because the signs are different. So I subtract the two numbers and my answer takes the sign of the larger number. Usually the adding and subtracting sign rules are a little trickier for us, because if I asked you, what do you get if you multiply a -3 times a -5, you'd tell me that's what? A +15, because as long as my signs are the same, or if I have an even number of negative signs, when I multiply, the answer will be positive. But if it had been a +7 times a -2, that answer would have been what? A -14. Okay, so quick signal on sign rules. Yay or nay? Okay, and if you still know you need a little work, remember you can have your sign rules with you while you're doing homework to just kind of double check yourself until you feel confident you know them without having to look at the rules. Okay, so we did all those things, and the last thing we did in class was we talked about how to convert from fractions and percents and decimals. And do we feel like we got that down okay? I hope so. The main one we'll probably be using is converting from percents to decimals, because we're going to get into working with formulas for interest. And when they give you an interest rate, it's always in what form? Percent. And so if we don't want percent, which we won't when we're working with the numbers in the formula. We're going to change it to decimal form in the formula. So if you can get from percent to a decimal and a decimal back to a percent, that's probably the main thing you'll use. But occasionally you may have something in a fraction form that needs to be changed. So we'll work more with that as we go along. Now, we're going to talk a little bit about what you're going to begin to see specifically in the 1.1 homework, and that is working with linear equations and making sure we understand the parts that are in that equation and how to graph them. So this is called standard form of a linear equation that's in one variable. So in other words, I only have one unknown, one variable. Usually it's x, but it could be any letter. And that's telling you when it's in standard form, you're going to have your x term first. If there are any other numbers being added or subtracted to it, it belongs on the same side where the x is, and it would be set equal to 0, okay? And the one rule is that your coefficient on that x term can't be 0, because if it were, what is 0 times anything?
0.
That would mean I wouldn't have an x term in it. So it wouldn't be a linear equation. Now, here's the deal. If I'm trying to solve, because I want to know what that unknown is. If I end up with something that's got an x in it and I'm trying to figure out what x is, these are the rules that I use. It will be equivalent. In other words, I'm not breaking any algebra rules if I add the same number to both sides or I subtract the same number from both sides. All right, think of it like a scale. And basically I always tell my algebra students, this is the cardinal rule of algebra. What thou doest to one side of an equation, thou must doest also to the other. So if I'm going to add something on one side to make something become 0, then I've got to make sure I add that same thing to the other side. Just like if I had a scale and I put 5 pennies on one side of the scale, it's going to tilt it unless I put 5 pennies on the other side of the scale. That's what would keep it balanced. That would also mean I could multiply or divide both sides of the equation by the same number as long as it's not 0. Okay, remember we can't divide anything by 0, and if we multiply by 0, it just makes everything become 0. But any other number, it's perfectly legal to multiply or divide each side. So let's try this one, and we're going to have to use a lot of those things we just reviewed in order to get this done, because I'm looking at this. Do you see how we have x's in more than one place? Okay, so here's all the things we're going to be combining out of what we reviewed last week. First of all, I'm noticing I've got parentheses, but what's inside the parentheses has x and a number. Are those like terms? No. So I can't combine what's inside the parentheses, but I have a number in front of the parentheses. So what property does that mean I'm going to need to use? Well, I'm going to be multiplying using the distributive property. So when I multiply through to get rid of the parentheses, that's the distributive property, and that's what we're going to do first, because I can't start putting any like terms together until I've gotten rid of the parentheses. Now, you're going to tell me what you think we need to write down. Is there anything I can do with this 8x yet? As we said, the first thing we've got to do is what? What's that property again? Distributive. We're going to use the distributive property first. So I have my 8x that I write down. Now, I'm noticing there's a subtraction and a 3, but did we say all subtraction could be changed to adding the opposite? We did, didn't we? So this is the same thing as 8x plus a negative 3. And I'm going to write it that way just so I remember what am I actually going to be multiplying through that first parentheses. Negative 3. Okay? If you don't think you need to change that to plus a negative, and you'll remember that the sign in front of a number stays with the number, and you'll multiply by negative 3, that's fine. I'm going to do it this way to help me remember. I'm really multiplying everything in the parentheses by negative 3. Yeah, you tell me what to write down, because that's going to be 8x plus, now what's negative 3 times x?
Negative 3x.
Negative 3x. I'm going to put a plus sign down. Now what's a negative 3 times a negative 4?
Negative 12.
Yeah, and it's positive, isn't it? Okay, and if you wanted to make that x minus 4 an x plus negative 4, feel free to do so. But I'm going to be multiplying a negative times a negative, and that's how I'm going to get a positive 12. I'm up to my equal sign, but at least I've gotten rid of the parentheses on the left side. What am I going to do on the right side now?
Same thing.
Same thing. And so I'm multiplying through by a positive 3 this time. So what do I write down first? 3x. Now notice I'm going to be multiplying 3 times what? Negative 4. And if you want to make that plus a negative 4 in the parentheses, you can do that. I'll go ahead and do that just so you can see it. Oops, that's really messy, sorry. But 3 times negative 4 is a negative 12. And then I have this plus 6 on the end. So that was step 1, is I went through and used the distributive property. Now, here's what you've got to take care of. I need to clean up on the left side of the equal sign. If I have any like terms, I'll combine them. After I take care of the left side, then I'll do the same thing on the right side. So if I look just on the left side of the 3x, or on the left side of the equal sign, I've got 8x plus negative 3x plus 12. Now, can you tell me, do I have any like terms over here?
Yes.
I do. These first two both have x in them. That means I can add those together. What is 8x plus negative 3x?
5x.
Yeah, we said last time, as long as they're like terms, if they've got the variables in there, then I'm adding up the coefficients. So the 8 plus negative 3 gives me a positive 5x. And then I still have this plus 12. Now I got to do the same thing on the left side. And I see 3x plus negative 12 plus 6. Are there any like terms there?
Yep.
The negative 12 and the positive 6. So that means my 3x is still here, but what do I get when I add negative 12 and positive 6?
Negative 5.
Double check, guys. Negative 12 plus 6. Sign rules say my
Or negative 6.
different. So I subtract the numbers, and then the answer is going to have what sign? The negative, because the 12 is bigger. So you can either write it as 3x minus 6, or you could write it as 3x plus negative 6. It doesn't matter to me which way you write it. You just have to be sure you've got a minus sign in there, and only one minus sign, okay? Now, at this point, I can't combine anything else on the left side, and I can't combine anything else on the right side. So now is when I've got to use that cardinal rule of algebra. I want to get the x's together on the same side. And remember, it said that I can add or subtract the same thing from both sides, and that's legal, okay? That's going to be a, that will keep things balanced as long as I do the same thing to both sides. So here's what I always tell my algebra students. Let's get the x's together first. And if you have either been taught or you've just always felt like x has to go on the left, I want to encourage you to think about it a little differently. How many of you say, ooh, I love working with negatives? Those are my favorite. They're probably pretty close to how much you enjoy working with fractions, right? What we want to try to do is keep from getting the negative number in front of our x if we can help it. So when I look at these two x values, I have 5x on the left and I have 3x on the right. Which one is bigger?
5x.
5x. I want to move everything to the side where the 5, where that has the bigger coefficient. So since 5 is bigger than 3, that means I want to get rid of the 3x on the right side. And the way I get rid of the 3x on the right side, if I have positive 3x there, I'm going to have to do what to make it go away? Subtract 3x. So I can either add a negative 3x to both sides, or I can subtract 3x from both sides, because as long as I'm doing the same thing to both sides, that's legal. And what happens is it makes the x's cancel on the right. What will I now have on the left side of the equal sign when I simplify this? 2x plus 12 equals, what's the only thing left on the right side now?
-6.
-6, very good. Because those x terms canceled out, but I'm left with a -6. Now, my goal is to solve for x. So eventually, I want x to be the only thing on the left side. And right now, x is being multiplied times 2, and then you would add 12. So, bless you, think about it this way. If I were trying to, if I had a number where x is, if I knew what it was, PEMDAS would tell me I would have to multiply it first and then add 12, okay? The problem is I don't know what the x is, so I can't do that. So when I'm trying to solve for a variable, I'm going to have to do PEMDAS backwards. Think about it this way. I used to use this illustration back when I taught in middle school and high school. If today was Sarah's birthday and we had taken up a collection and we were going to give her a gift, okay? And this is what we would do. We would send Sarah out in the hall and I would have some sort of gift. And in order to wrap it up, I would take it and I'd put it in a box, right? And then I'd put the lid on it. And then what would we probably do with it? Put some wrapping paper around it, and we'd tape it down, and maybe put a ribbon on it, and it would be a nice, pretty gift ready to give Sarah. So she'd come back in, we'd all sing, and I want you to think about this. That gift is like our variable. There's something we're trying to find. We don't know what it is. So when Sarah is thinking, wow, they got me a gift, I'm wondering what it is, what's she going to have to do first to get to the gift? She's going to have to take the ribbon off, which was the last thing we did. That's got to be the first thing she undoes. Then she's going to do what? Take off the paper, because remember, right before we put on the ribbon, we wrapped it in the paper and taped it down. And then after she gets rid of the ribbon and after she gets rid of the paper, then she can take off the lid to see what the gift is. That's why we use PEMDAS backwards when we're solving for x. It's the same idea as when you're unwrapping a package. You got to do it in reverse order of how it got put together, okay? So what I'm going to ask you is, what do you think we're going to have to do to try to get that x by itself? What remember, it's PEMDAS backwards. So the first thing we need to undo on the left side is to do what? -12, because remember that x, if I knew what it was, would first get multiplied by 2, then you would add 12. So I got to go in reverse order. That means I undo addition or subtraction first. So if I subtract 12 from each side, that leaves me with 2x equals, and what would a -6 plus a -12 be?
-6.
Ooh, be careful. Remember, subtraction is the same thing as adding the opposite. So I'm adding numbers whose signs are the same. What does the rule tell me to do? Keep the sign, but do what with the numbers? Add the numbers. So -6 plus -12 is what?
-18.
-18. And if you need to use your calculator to double check yourself, you can do that, but you need to get confident with these sign rules. Now, if 2x is equal to a -18, what would I need to do next? Divide both sides by 2. So if I divide by 2 here and divide by 2 here, dividing by 2 lets me cancel those 2's, and x would equal what? -9. Now, that will be the correct answer, but if I wanted to make sure that was right, what could I do to double check it? Couldn't I plug it back into the original and make sure the left side equals the right? And this is where your calculator can be helpful. Let me see if I can get it. calculator up on the screen for a second. Hold on. Let's go back to there and no, that's the calendar. Sorry, I don't want that. No, let's go back. Well, let me just say, if you pull up your calculator, you could do 8 and then in parentheses, multiply it times -9, and then do -3, and in parentheses, you could do -9 minus 4, and then hit equals and write down what that number is. Then you can go to the right side and do the same thing, where every place you've got an X, you put in the -9. Use your parentheses on your calculator. I would type it in the way that it looks in the original problem, and then that way you can make sure the left side equals the right. Okay, does that make sense? That is solving a simple linear equation, but there was a lot for us to remember in there. We've got to know our sign rules, we've got to know the distributive property, we've got to know how to combine like terms, okay? So a little more practice just to get more confident. Then let's look at this one. We're going to solve this linear equation, and this time we will check the result, and I'll show you how you can do that. Now, I'm sure you guys are thrilled to see fractions. We all love fractions, right? Okay, it's deadly silent over here. I sort of suspect the same could be true in Carol. By the way, did Dana ever make it, or is she still not there?
No, she's not here.
Okay, but Daniel is?
Yep.
Okay, because, yeah, and be sure, is Daniel logged in?
Yeah, he's right.
Yeah, he's right here.
No, well, I know he's there. Is he logged in to where he's looking at the Zoom meeting on his computer? Yeah. Or is he just looking on with you guys?
No, he's on the meeting. I see him on the screens.
Okay.
He's my bottom
the reason I'm asking is because for some reason I'm not getting all the tiles.
Oh, okay.
Okay, there we go. I see you now. All right, so Daniel, I need to make sure you get everything set up in my math lab before you go today, okay? So hang on there. All right, let's do this. If this is what I'm going to need to solve right here, if I were to ask you, would getting rid of the fractions make your life easier here? What would you say? Okay, at least Sarah would like to get rid of the fractions. I don't know about the rest of you may really like it, because think about it for a second. If I don't get rid of the fractions, I'm noticing on the left side, there are two fractions here, and there's a minus sign between them. If I'm going to add or subtract fractions, what do I have to have? A common denominator. And one of these is 2, the other one is 3. That tells me I'm going to have to multiply both fractions by something to get a common denominator. And that makes me a little nervous because now there are X's involved and all kinds of messy stuff. So let me make a suggestion. Here's what we're going to do. We're going to go ahead and figure out what the LCD would be, the least common denominator. So if I were to ask you what's the smallest number both 2 and 3 would divide into evenly, what would you tell me? 6. Okay, so what you're going to do is first find the LCD, okay? And if you want to put these notes out to the side, what I'm trying to give you are the steps for solving an equation that has a fraction in it. Okay, so you got to have an equal sign before you can do this. Don't think you're about to learn a trick that lets you get rid of every fraction. No, if there's no equal sign, like the ones we did last week, and the one we did in that quiz where you had 1/25 plus 2/5, there's no equal sign there for me to be able to get rid of the fractions. But when there is an equal sign, I can get rid of fractions if after I find the LCD, I will multiply every term. That means both sides. By the LCD. And it's the LCD over 1. Okay? In other words, when I find that common denominator, I don't multiply top and bottom by that number. I'm just multiplying the numerator times the LCD. So think of it as the LCD over 1. What that's going to let me do is cancel out the denominators. Okay? So let me show you what I mean. And I'm going to erase what I just wrote down as far as the rules, so I've got some room to work. And you guys told me the LCD was 6. So here's what we're going to do with it. I'm going to recopy this. X plus 2 over 2 minus x over 3 equals 5. And I'm going to multiply the first term by the LCD over 1, 6 over 1. I'm going to multiply the second term by the LCD over 1, 6 over 1. I also have to multiply this side by the LCD, even though there wasn't a fraction there. Because remember, what you do to one side of the equation, thou must doest also to the other. So I can't just multiply the terms that have fractions by the LCD. I got to multiply everything by the LCD. Does that make sense? That's legal, right? As long as I'm doing the same thing to both sides, then it will be equivalent. Now, watch the magic. Look at your first term. You have 6 over 1 times x plus 2 over 2. Remember, when I'm multiplying fractions, if I see something that is a common factor between numerator and denominator, what can I do with it? Can I reduce? I sure can. 2 goes into 2 one time. How many times will 2 go into 6? 3 times. Look what I have now. I have 3 times x plus 2 in parentheses, and all of that's over 1. When it's over 1, I don't have a fraction anymore. That's the magic. Now, what's going to happen in the next term? Because I have a 3 on bottom and a 6 on top. What can I do with that? Divide both by 3. 3 goes into 3 one time. 3 goes into 6 2 times. Now, tell me what to write down. I've got my minus sign, and then what? 2x. I'm up to the equals. Now, what goes on the right side? 30. 5 times 6 is 30. Voila. We now have no more fractions. And this is perfectly legal to do as long as you've got that equal sign there, correct? Okay, what would you do next? Because remember, our goal is to solve for x. We want to find out what x is. So what would you do next? Distribute. Go ahead. You can tell me what to write down. Go ahead, James.
3x plus 36.
Plus how much? I'm sorry?
36. Because you're doing 3 times 12.
And this is actually a 2 in the parentheses. So it's 3 times x plus 3 times 2, which is 6, minus 2x, and that's equal to 30, right?
Yeah.
Okay, yeah, I probably wrote a little sloppy where you couldn't tell what it was. So we've distributed now by multiplying everything in the first parentheses by the 3. Do you see some like terms on the left side? Yeah, so if I put these x terms together, what would that equal? Very good. It's a positive 1x, isn't it? If I have 3x and I take away 2x, that gives me a positive 1x plus 6. And if you want to put the 1 in front of the x, you can, but you don't need it. And then you would do what? To get x by itself, subtract 6. And if I do it to one side, I've got to do it to the other. And that means x equals what number? 24. Now, it said we want to be sure and check it. So if I go back up to the original problem, when I check this, I'm going to put 24 plus 2 over 2 minus 24 over 3, and I'm going to see if that equals 5. So how much is 24 plus 2? And if I take 26 and I divide it by 2, that's how much? What's half of 26? 13. Minus, all right, how much is 24 divided by 3? 8. Does that equal 5? Yes, it does. So it checks. So plugging it back in to the original problem is how you can make sure you get it right. Now, what I will tell you is on some simple things like this, you can either mentally check it or you can do it in your calculator quickly until you get really confident that you know the right order to solve these in and you're using those rules correctly. We're also going to discuss as we get a little further along how sometimes, especially with some of these formulas that we'll use that are kind of complex, part of what we do is just sort of check to see that our answer is reasonable. And there'll be some things that you ought to be able to look at and go, oh, there's no way that one would make sense. So you can always plug back in to verify, but then there'll be some things too where you can just kind of tell in the problem if your answer is reasonable. And a lot of times on these formulas that we're using in math for business, if you're doing that, you'll catch yourself before you put down some answers that couldn't possibly be right. Okay, any questions up to this point, or are we good? Then let's talk about what changes if that equal sign isn't an equal sign anymore and it turns into an inequality. Now, inequalities are your greater than, less than signs. Has anybody ever had trouble trying to remember which is which when you see it? Okay, think about it this way. When you read inequalities, because we are English speaking language people, you read English going from left to right, correct? So when you're reading these signs, you're doing the same thing. As you move across from left to right, think about it this way. And I know this is very simplistic and basic. Have you ever heard the story about greater than Gator? Okay, I've got one that says yes. This is if you have little ones at home, or one day you have little ones, you could maybe help them out this way. Greater than Gator, he's this alligator that lives in Florida. Of course, he's probably hunkering down right now trying to avoid the hurricane. But this little boy noticed, because they lived where the alligators would come up in their backyard, and he noticed that when they they would have like a compost pile. So they actually had 2 of them. One was a big one, one was a little one. And he noticed every time greater than Gator came up, he would always go to the big pile, because the gator, when his mouth is open, is always going to open to the biggest thing. So when you're reading this and you go from left to right and you see the point, that's not his open mouth. That means this side is less than what's on the other side. Okay, so when you see the point first going left to right, that's a less than sign. If you see the open mouth first, that means it's a what? Greater than sign, because his mouth is always going to be open to what's greater. Okay, and this is just telling us that just like we said we could add the same thing to both sides when we have equal signs, and that keeps it balanced, and we can subtract, those rules also hold with inequalities. So if it's a greater than or equal to, less than or equal to, you can add or subtract anything from both sides, and that doesn't affect the inequality at all. Okay, now let's pull up a little bit and let's just practice to make sure we know which sign goes where. So what would you put in between 3 and 5? A less than, greater than, or an equal to? Less than, because the mouth has to be open to the biggest thing. What would you put between a -6 and a -2? Very good. If they're both negative, you kind of have to think opposite, because remember, when you're on the left side of 0 on the number line, if we were looking at the numbers and thinking about absolute values, then we would think, well, 6 is bigger than 2. It's true when they're positive, but if you're on the negative end, because it's talking about distance from 0, would you mind closing the door for me? Okay, then the -6 is actually further away on the left side from 0 than -2 is. So what would be true on the positive side actually looks opposite when you're on the negative side. And then what would be true when you compare 0 and -10? What would go in there? 0 is greater than -10. Very good. Okay. Now, I already told you can add or subtract anything from both sides with inequalities, and it doesn't affect the inequality. But we have to be careful if we're multiplying or dividing. So as long as I'm multiplying or dividing by a positive number, it does not affect the inequality sign. So I can add or subtract, and I can multiply or divide by a positive number. Nothing happens to my inequality. But I got to be really careful if I ever have to multiply or divide by a negative number. If I multiply or divide by a negative number, guess what happens? The inequality reverses. Okay? Now, let me show you something really basic that hopefully will make sense as to why you're going to have to reverse it. So let's say we had something like a -x plus 1 is less than, we'll just put in 3, okay? A -x plus 1 is less than 3. Now, if I needed to solve this, I want to show you just a couple of things here. What would you think you'd need to do first? Subtract 1. So if I were to subtract 1 from each side, then I would have a -x is less than what number? 2. Have I finished? Because I don't know what x is either greater than or less than. I know what -x is less than. So what would I have to do to turn that into a positive x? Okay, so if I'm going to follow this rule here, and I'm going to divide by a -1, that's when I have to remember that this inequality reverses. So what I'm going to tell you is, if you're going to have to multiply or divide by a negative, I would circle that inequality when you show that you're multiplying or dividing by a negative to remind you on the next step, you better do what with it? Reverse it. So a negative divided by a negative gives me a positive. And that's going to now go this way. And a +2 divided by a -1 is what? What's a positive divided by a negative? Tell me the sign. A negative. So that would tell me that x has to be greater than a -2. Does that make sense? So if it's greater than a -2, does that mean it needs to be a number that's bigger than -2 or smaller? Bigger, right? To the right of -2. Is -1 bigger than -2? Yeah. So if I went back up here and I tested this out, -1, what's a negative? Think for a second. This is like -1 times -1. Negative times a negative is a, so that would give me 1 plus 1, which is how much? 2. And that tells me 2 is less than 3, and that's true. Let's try something that's a lot bigger than -1, like maybe 6. Okay, so if I were to try putting in a 6 for x, that turns into -6 plus 1, which is how much? Is -5 less than 3? Okay, so we know this answer is correct. Let me just show you another way. If you're, and I like to teach this just because I know there are some of you that you're like, I will never remember to flip that inequality. If I have to multiply or divide by a negative, that's going to mess me up. So let's say you started with -x plus 1 is less than 3. And you said, okay, I see my x is negative. I don't want it to be. Remember, we can add or subtract anything to both sides and it doesn't change the inequality, right? So what could I do to get that -x to go to the other side? What would make it go away on the left? If it's a -1x, I could do what? Add 1x, right? So if I add x to both sides, it cancels over here, and I would have 1 is less than 3 plus x. Now, I would do what to get rid of the 3? Because I want to get x by itself. How can I make this 3 disappear on the right side? Subtract. So if I subtract 3 from both sides, then how much is 1 minus 3, or 1 plus a -3? That would be a -2, and I have my less than sign, and I have x. Now, the problem is the x is on the right. In an equals, it doesn't matter. With an inequality, that might look a little confusing. But here's all, just think about greater than gator. I can put the x on the left side. When I do, I just have to be sure that the gator mouth is still pointed the same way in relation to the x as it is here. Since it's open to the x, I'm going to make it open to the x. And notice this is the same. Okay? So you can usually avoid having to multiply or divide by a negative if you want to take maybe an extra step in the beginning and get the x term to the other side so it would be positive if it started off as a negative. Your option. But if you're going to multiply or divide by a negative, you got to remember that you'll have to reverse the inequality. So give me a quick signal. Are we here, here, or here? What do you guys say? Okay, Daniel's giving me a thumbs up. All right, so is James. You guys good? Okay, so we're going to practice this a little bit and clear this off. And we're going to talk just a second about something called interval notation. How many of you have heard of this before, interval notation? You know what this, okay, I've got a few hands. Interval notation is a way to explain what your solution set is when you're working with inequalities, because we just wrote x is greater than -2, okay? And I'm going to go ahead and use that as my illustration here. If I were to put this on a number line, okay, think back to probably middle school. And if you did some graphing with a number line, then, you remember when you had inequalities, how would you show? I want you to start at -2, but don't count it. There was a different way that we showed if we were supposed to include that number or not include the number. Because is -2 greater than -2? Yes or no? Is -2 greater than -2? Yes or no? It's not. So I want to start at -2, but I don't want -2 to be part of my answer. Do you remember what we would put there back in probably middle school? It was either an open circle or a closed circle. What was the difference? Which one means don't count this? Open or closed? Closed means count it. If you color it in, it means this is part of your solution. If you leave it open, it means don't count it. And then because it's greater than, I would draw a line that looks like that. That would be the graph of the solution set. Notice if you've got the inequality, your arrow will always go the direction that the arrowhead is pointing in the inequality. So since x is greater than -2, after I put the circle, I'm going this way. Now, yes, sir?
The only time the circles go down is if equal, correct?
Correct. If it has a line underneath the inequality, if it had looked like this,
Yeah, like if it's greater than.
correct, then you would color it in and make it a closed circle. So if it doesn't have the or equal to, it would be open. If it does have the or equal to, you color it in and make it closed. Now, if we wanted to express this in interval notation, just like I have to have something different to show between the open circle and the closed circle to explain whether I count that number or not, I've got to have the same thing with interval notation. But it's the same idea as this. Instead of drawing out the graph, though, I can say I'm going to start with this number and it's going to go till whatever place it ends. So for what we have written here, I'm going to start at -2. And then how far does this go? Is there a stopping point? There's not. So if there's not a stopping point and I'm moving to the right, is this moving toward positive infinity? Yes. Now infinity is that sideways 8 symbol. Now I have a question. Is infinity a number or is it a concept? It's a concept. It's the idea. I was trying to explain this. We were talking the other day, my 5-year-old granddaughter and myself, and she was talking about how she could count to 100. And I said, that's awesome, Caitlin. And she was talking about her mommy, and she said, I know mommy can count higher than that. How high can she count? And we started talking about the idea that no matter what the biggest number is you think of, can you always add one more to it? And that numbers never end. Now that's a real hard concept for a 5-year-old to grasp. She does not have that yet. But that's the idea behind, it's sort of a Buzz Lightyear moment, to infinity and beyond, okay? If infinity were a number, you could go past it. But it's just the symbol to explain this is going to go on forever. So here's the idea. When we're using interval notation, if something is included, like this one is with the closed circle or the or equal to, we're going to put a squared off bracket to show not only do you start here, but this is part of your answer. Okay, so we start at -2 and it's going to go on forever. Since infinity is not a number, it can't be included. And that means we'll use an open parentheses to close off things that are not included. In other words, it's kind of a soft boundary. Yes?
Does it matter if you solve the you have like a bracket?
No, that, in fact, let's look at that. So if we had something that looked like this, and let's say we had something that started at 1, went to 4, and everything in between was included. How would that look using interval notation? We go from 1 to 4. Is 1 included? Yes, so it would need a bracket or a parentheses. Bracket. Is 4 included? So it would need a bracket. So you can have 2 brackets, you can have 1 of each, you can have 2 parentheses. You've just got to be sure that you always go from least to greatest. So you would go from left to right. Now, let's say we had something and it was like this. So let's say this was 1. And we have an open circle here, and we're going to the left. And we wanted to express that using interval notation. So remember, you got to go from least to greatest. What would be the smallest number in this solution set? And is it positive or negative in direction? It starts at -infinity, and it continues until you get where? To 1. Now, what would go around -infinity? Parentheses. And what would go around 1? Is 1 included?
Oh, yeah.
So it would need a parentheses. So you've got a lot of different ways that interval notation can look, but basically it's the idea of it starts here and goes until you get to this point, and then you've got to choose the right symbol to indicate whether it's included or not included. Does that make sense? We'll work with this. You'll have a few questions where you will be asked to express your answer using interval notation. Okay, let me clear this off. All right, and here is symbolically what all of these options look like. It gives you the interval notation form. It shows you what it would look like if you were using the inequalities, and it shows you what it would look like using graphs. Now, the only thing they changed on the graph is instead of open circles and closed circles, they used the bracket and the parentheses. But that's a good thing. That makes it easier to remember. Excuse me. So let's see if we can explain this in a way that would make sense. So an interval is closed if what is true? If it's closed, it means that it would have the bracket around it. And it's closed if what? Yes. If, and actually, let's put it this way, an interval is closed if there are two endpoints. Okay, that's how you're going to get two brackets, is if you have two endpoints, a start and a stop on your graph. Now, the square bracket is used to indicate what? In other words, if it's part of the solution, right? So is used to indicate it is included. So it is included in the solution. But an interval is open if the interval what? Yeah, if the interval, and let's write it this way, doesn't have two endpoints. I'm not sure why the blank is so small, but that's what we would put there. Okay, so that means if it goes on to infinity, even if there's a bracket on one end, it's still an open interval because you have to have two endpoints and everything in between for it to be closed. So if I don't have two endpoints, I have what's called an open interval. And the parentheses indicate that the endpoint is, if they've got parentheses, is the endpoint included or not? That's right, the endpoint is not included in the interval. And we know parentheses are always used for negative or positive infinity. Okay? All right, so let's look at just a little bit more in here. Let me clear this off. Keep doing that. Let me pull it up. And this looks a lot like what we did a moment ago when we were working with the equations, but now we've got an inequality in here, okay? So if we notice that we've got less than, greater than, and sorry, this should have the or equal to under it, so let's fix that. Less than or equal to, or greater than or equal to, then we say we have a first degree or a linear inequality. So we can still solve for x here. We would just end up having to make sure we don't lose the inequality. Now, I will tell you on this one, we could get rid of the fraction if you want, if we did what? What would we have to do with this? Yeah, the only fraction here has a denominator 2. If we wanted to multiply everything by 2, we could do that to get rid of the fraction. We're not going to go through that right now. Instead, let's just work on something that's a little bit simpler, because I think that's going to be more like what you see in your homework. And we're going to solve this linear inequality. So, solve this inequality and give the solution in interval form. And we're going to graph it as well. So if I have 2 times 2x plus 3, which is less than 6 times x minus 2, just keep that inequality like it is as long as we are not moving things from one side to the other. We get to a point where we get ready to move things from one side to the other. We can add or subtract anything, and we can multiply or divide by positives, and it doesn't affect our inequality. So tell me what you would do first. Yeah, now when I look at parentheses, can I combine what's inside the parentheses? They're not like terms, are they? So how could I get rid of the parentheses? Use the, what's that property? Help us out, Terrell people. Distributive, there you go. So let's multiply everything in this first parentheses by 2. What are we going to get? 4x plus 6 is less than, and now let's take care of the right side. Can we distribute there? 6x minus what? Be careful. Yeah, we're going to have to multiply everything in the parentheses by 6. So 6 times x is 6x. And then if you want to think of that as plus and negative, we're going to have plus 6 times negative 2 is negative 12. And then I have a plus 10. Okay, are we good on getting rid of those parentheses? Everybody okay? All right, now what would we do? Can we do anything on the left side of the inequality? No, because they're not like terms. What about on the right side? What can we put together? Yeah, the negative 12 plus 10. Those are like terms. So I'm not going to change anything until I get there. And what do I get when I add negative 12 and a positive 10? Excellent. So I have 6x plus negative 2 on the right side. Okay, what did I suggest you put together first? X's or the plain number? I would get the X's together. And if it's up to me, I would move which one? What do you think? I'd move the smaller. Let's move the 4x because I think it's easier to reverse the inequality when I am at the end than to try to remember to do it in the middle. So I'm going to subtract 4x from each side. That would give me 6 is less than, now what's on the right? How much is 6x minus 4x? 2x plus a negative 2, right? Okay, now what? Well, all right, very good. I'm wanting to get x by itself, and it's got this plus negative 2 on the end. So to get that negative 2 to go away, I've got to add 2 to both sides, right? Okay. So 6 plus 2 is 8, is less than 2x. What would I do now to get x by itself? Divide by 2. And I have 4 is less than x. Now, writing it that way with the x on the right is going to make it harder for me to figure out what this thing should look like. So is it possible to turn it around and put the x on the left? But when I do, what do I have to do with that inequality? It's going to turn into a greater than because the mouth has to be open to the x, so 4. That's my solution. I personally think it's easier to take this, put it on the graph, and then from there write the interval notation, but it's up to you which way you want to do it. It asks for all of these because we've got the inequality. We've got to also get the graph and the interval notation. So if I were to put this on a graph, What am I going to put it for? And you can do circles if you want, or it might help us out if we use parentheses or brackets. So what do you think would be needed based on this inequality? What do you say? An open circle or what goes with an open circle in interval notation? Parentheses. And because this greater than sign tells me the arrow is going to go to the right, if I use the parentheses, I could put the open parentheses there and draw it that way. If you wanted to put the open circle there, that's fine too. Now, how do you, yeah.
Do you make the test or just like Steve and David?
No, I make the test. So, and we'll be doing those on paper and not in the computer, but they'll be similar to the kinds of questions we've done in homework.
Are you picky about parentheses or?
No, on the graph, if you give me the correct circle, either open or closed, instead of parentheses or bracket, I'm good with that. Okay, as long, because either way is fine. Now, how would we write this answer in interval notation? What would you put down first? The 4, because remember, we do it in order from least to greatest. So when I'm looking at this graph, the first thing I come to is the number 4. And it goes to where? Positive infinity. And then what do I need to put around the 4? A parentheses. What do I put around infinity? There you go. So here's interval notation. Here's the graph. Here's the inequality. Okay, give me a quick signal. Are we here, here, or here? The inequality is this, okay, where you see the greater than or the less than. This is interval, where it would be 2 values, a start and a stop, enclosed by either parentheses or brackets, and then in the middle is your graph. Okay, now sometimes, you know how we said you'd have, the only way you get a closed interval is when you have 2 what? Endpoints, right? You got to have a start and a stop, and it doesn't continue on toward infinity. Those a lot of times are written like what you see here on this example, where your x is getting squeezed in the middle. So let's talk about how we can do that one. And again, remember, the cardinal rule says we can add or subtract anything on both sides of an equal sign. We could add or subtract anything on both sides of an inequality, but look here, we've got 2 inequalities. So there's really 3 places. There's a left, a middle, and a right. Same rules. The only difference is now, instead of doing it 2 places, you have to do it all. So my goal is to get the x by itself. Is it already in the middle? Now look at what else is in the middle with it and tell me which part of what's in the middle do we need to get rid of first? The positive 3. How would I get rid of it? I'm going to have to subtract 3, not only in the middle, but on the left and on the right. Make sure when it's this double inequality that you, whatever you're doing, you do in all 3 places. So tell me what number belongs on the left now. If I have -3 and I add a -3 to it, that's how much? -6 is less than. Now in the middle, that canceled, so I have 2x, which is less than, what's on the right side? +6. +9 minus 3 is 6. What would be the next thing that has to happen? Divide by 2. And if I'm going to do it in the middle, I've also got to do it on the left and on the right. What's -6 divided by 2? Which is less than x, which is less than 3. Does that make sense? Okay, so can you graph that now? And could you write it in interval notation? All right, and give you a second to do that, and then we'll compare and see if we've all gotten it right.
Good, I guess.
Okay, so we're having a little bit of trouble here. Let me just kind of help you guys out. So when I get ready to graph this thing, if I have -3 here, +3 here, and it tells me that all of my x's are between a -3 and a +3, then I'm going to start at -3 And I'm noticing here, more people seem to be comfortable with open and closed circles than parentheses and brackets, and that's fine. So I'm going to put the open circle at -3. Why would I not color it in? Because I don't have an or equal to. If I had an or equal to, I would color it in. But since I don't have one, I'm going to leave it open. And then I'm going to do the same thing at 3. And since all of my values that are solutions are between, then I connect those two open circles. That's the way the graph would look. Because everything that's a solution has to be between -3 and +3. Now, how do you write that in interval notation? I start at -3, I go to +3, and what does that need to be enclosed by? Parentheses or brackets? Parentheses, because it didn't have the or equal to. If it had the or equal to, then it would be brackets. Okay, did you guys get that in Terrell? Yes? Okay, so does that help a little bit? It takes a little practice, especially if this is something you've kind of forgotten because you haven't done it in a while. All right, and then we've got more of a business application we're going to look at. All of this stuff is getting you ready to do the homework in section 1.1. So when we go through the notes for 1-1, we're going to be doing more of this stuff that we've just covered today. So this would give you enough to hopefully get going in 1.1, but we'll clear up some of the questions you may still have when we finish those notes in 1.1. Now, if you're going to own a business, or if you're going to be employed for a business and part of your job is to try to make sure that the company doesn't lose money, because clearly that's not a good thing. If you're losing money as a business owner, you're not going to be in business very long. So a lot of times you will hear people talk about a profit loss analysis or a profit loss statement. If you owned a business and maybe you wanted to expand, I can guarantee you if you will go to some place and try to borrow money, they're going to want to see your profit and loss sheet. They want to know what is the health of your business. Are you making money or not? So that's also going to be very important to help you decide if you're selling some kind of product. How do you come up with the best price? I mean, think about it. Do I have any Starbucks drinkers in here? No. Wow, I'm surprised. Okay, well, I see maybe in Terrell, we've got a few. Y'all do have 2 nice Starbucks in Terrell. We just have a little thing on campus here. That's it. But let's just use that as an example. If somebody had told you, you know, you can have something to drink for 50 cents, or you can, my husband won't, he refuses to call Starbucks, he calls it $5 because you can't get practically anything to drink for less than $5 there, okay? And if you were trying to decide between 2, you just wanted something to drink, 50 cents versus $5, okay? If that's all you were looking at, we would go with 50 cents, right? I mean, in fact, let me put it this way. If you're a coffee drinker and Starbucks had a 50-cent day, I bet everybody would not hesitate to go to Starbucks. But how many of you, if you don't drink Starbucks, is it because you don't drink coffee or because I'm just not paying what it costs to get a drink there? Okay, for some of us, it's like,
I don't drink coffee.
no way, I'm going to spend that kind of money on something that I think is overpriced. Now, here's the deal. Somebody at Starbucks has run an analysis to figure out what is the best price for us to set on our product. Because would we all agree that they're obviously making a lot of money on each cup that they sell based on their price? Absolutely. And what they look at is, when we raise our price, are we going to lose customers? And there's going to be a point where you're looking for the sweet spot, basically. If you reduce your price and made it something we'd be willing to pay, they're going to make less money on it. Yes, they get more customers, but they have done an analysis and they've decided, even though we lose some customers by going with this higher price, our profit is so much more And the ones we lost, that doesn't really impact us. We're doing better selling this higher price to fewer people than if we lower our price. Okay, that's kind of the way, that's the business model that they're going to look at. So in order to do these calculations, there's some things you have to know. First of all, you've got to have an understanding of what are your fixed costs. Now, can you tell me what types of costs would be fixed? You're going to have these even if you don't sell one thing all month. If you own a business, what are you probably going to have to pay out regardless of whether you sell anything? What do you say? Okay, bills and things that would be your typical bills. You might have rent, or it's possible you could have a mortgage payment. What else do you think you would have regardless of whether you sell anything? Yeah. Yeah, even if I don't sell anything, what would I still have an expense for? What's the government going to want from you? Taxes. There you go. Taxes. You'd probably have insurance, because if you've got like a loan, equipment, if you've had to get a loan to get some equipment, you're going to still have to pay on that equipment even if you don't make anything. And if you've got equipment, they're going to make you have insurance. What else?
You don't have to buy it first.
Yeah, now that's actually going to be what we would call a variable cost, because what he mentioned, it would be like merchandise or supplies. Okay. All right, now which do you think utilities would be, variable or fixed? It's variable in the sense that it might not be the same amount every month, but are you going to have to pay it every month even if you don't sell anything? So I would say utilities would probably come up here under fixed. Did you think something else? Oh, okay. And are you... There you go. Wages or labor, we'll put it that way. Now I'm going to put that variable, but again, that could be fixed if, say, you've got salaried employees that you're going to have to pay them regardless of whether anything gets sold or not. If you've got people that you're hiring by the hour to work when you need them to work, that's going to be more of a variable cost. I won't be paying that unless I actually have something for them to do. So there's a lot of different types of expenses you'd have to be aware of. Now, here's what you look at when you start trying to make those comparisons to figure out, is my business healthy? Is it doing well or is it not? So you need to know your revenue. What does revenue mean? Income, the amount of money that you are collecting for whatever service you're providing in your business, okay? That your revenue doesn't take out anything for expenses. Your expenses are your costs, okay? And that would be both your variable and your fixed costs. So if I have more revenue, more money that I bring in than what my costs are, that would be this one right here, then I would make a profit. That would be my goal, right? Yeah.
Revenue, is that the same thing as like gross?
Your gross income would be your, yes, your total revenue, the amount that you're bringing in. Net would be what you have after you take out for those costs, and that's your profit, okay? So if we don't bring in more revenue than what our costs are, your company is losing money. Now, would you think if you are starting a company, are you likely to make a profit on day one? No, there's usually, if you heard of startup costs, usually if you're going to start a business, you need to understand you got to have kind of backup funds to carry you over in the beginning, because it's going to take a little while for your revenue to reach a point that it covers your costs. And if they're exactly the same, if you bring in exactly the same amount of money as what it costs to produce that, that's called your break-even point, okay? So to find your profit, all you have to do is revenue minus cost. To get your profit, if your profit is less than zero, if you're in the red, it's negative, what did your company do? Did it make money or lose money? The company lost money. What about if the profit is 0? Then you break even. The company breaks even. And what if your profit's greater than 0? That's right, you've made money. So the company makes money. Okay? So those are the 3 possibilities of what can occur once you calculate your profit. Okay? So it's often helpful to find when the company breaks even, and we call this your break-even analysis. That's sort of like, think about it, with a startup, that's going to be an important point to reach, because once you reach that, you know you're about to turn a profit. So let's look at this. We've got, and this will be the last example, and then we'll be through with this packet for a little bit. A university club plans to raise money by selling custom printed t-shirts. So they find that it charges $400 to create the artwork, and then they're going to charge $3.50 per shirt that is printed. So if they sell the shirts for $15 each, how many shirts would they have to make and sell in order to break even? All right, so that would be important to know. If I'm, and part of the reason is, I mean, obviously, if I'm agreeing to do this, then I need to figure out how many shirts they better be ordering in order for me to be able to make money, okay? By the same token, if I'm the person buying the shirts and I'm gonna have to pay this, I need to figure out exactly what it's gonna cost, because it might not make sense for me to order these if it's gonna make each shirt terribly expensive because of having to pay for the artwork. So tell me how we can calculate what the revenue would be if, say, we go into this agreement and I'm making the shirts and selling them. What am I going to be collecting in revenue? Okay, now hang on a second. They're actually selling the shirts for what? Okay, they're going to be selling the shirts for $15. So if X is the number of shirts, okay, then what, because remember, they're getting these shirts made and they're going to sell them. They're going to be bringing in 15 times however many shirts they sell, right? That's their revenue. Now, what did it cost them in order to get these shirts to sell? $400 off the top, because they had to pay for the artwork. Then what, did they have another expense? Okay, so it would be $400 plus an additional $3.50 times each shirt. Does that make sense how we just wrote these out? All right, so I have to know what the amount is that I'm going to get for every shirt that I sell. I have to know what it costs me to make the shirts. And then what would I do to find my break even? Break even occurs when what's true between revenue and cost? They're equal. So I'm going to set revenue equal to cost, which means 15x is going to equal 400 plus 3.5x. Okay. So what would we do now to solve this? Because I need to know how many shirts I'd have to sell to break even. Well, if I look on the left side, I only have one thing there. On the right side, I have 2 terms, but they're not like terms. So she's saying, Lisa's saying, let's get the x's together, right? And to get the x's together, I'm going to do what to both sides? Excellent, minus 3.5x. So what is 15 minus 3.5? $11.5x is equal to 400. Excellent. You're going to want a calculator. You divide both sides by 11.5. And you do not get a nice, pretty number. You get something like what? 34.78, dot, 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 dot. Now, in the real world, are you going to sell 78 hundredths of a shirt? So how many shirts are you going to have to sell in order to break even? There you go, 35 shirts. So then I could decide, well, you know, I really think we're not going to have any trouble selling 100 shirts, so we're good, because clearly everything after 35 shirts is going to allow us to make profit. But I have to sell at least 35 shirts to break even off my expenses. Okay?